Hello, all of you. Welcome. Okay, once again for our CCNP security session. We finished the theory part of VPN. Today we'll do practical, and in the practical session also I will explain how the site-to-site VPN take place, how things work in site-to-site VPN between two routers. So let me open my topology. You can see here I have placed two routers. They are connected with each other. Let me wipe those devices and start. Let me share my screen. In this, we are having two routers, R1 and R2. Today, we are going to do site-to-site VPN practical between two routers. And we are also having two routers to act as a LAN. So we'll first go and see what is the configuration. You see the basic configuration is already there, where I can pin my another device perfectly. I can ping 172.16.10.1 and 10.2. 10.2 is R4, that is branch PC. So yes, I can ping now branch PC. R3 is LAN PC of head office. So his IP address is 10.2, 192.160.10.2, and he can reach 172.16.10.2. So end-to-end reachability is there, but the only problem is there is no VPN. So whenever the traffic goes without tunnel over internet, okay, whenever a traffic goes without tunnel over internet, might lose data confidentiality, integrity, and authenticity. So in order to protect that, we are going to do IPsec VPN, and in IPsec VPN also we'll do site-to-site VPN between two routers, R1 and R2. So the first command that we are going to use is crypto. Now earlier we used to use the command ISAKMP. Now also if you see, but when you use ISAKMP means earlier it was IKE version 1. If you are using IKE version 1, you can use the command ISAKMP, but now you have an option for IKE version 2 also. So first we'll see what is IKE version 1. Okay, then we'll see the difference between IKE version 1 and IKE version 2. So the command is ISAKMP policy. And when you put a question mark, you see there is a priority of protection suite. Priority means I told you when I showed you the IKE phase 1, IKE version 1 phase, IKE version 1 modes. I told you or explained you about main mode and aggressive mode. So in main mode, negotiation of policy, DP element exchange, and peers identity is taken into consideration. So when negotiation of policy takes place, phase 1, they always match with the policies. Find out the exact policy. Number or priority number is not important on both the firewall or both the routers. You can keep 10 here, you can keep 11 there, you can keep 10 and 10 there also, not a big issue. But when it comes to the word priority means, if he noticed that there are 3 policies where the algorithms are same, that is the haggle. Haggle means, I told you last time, hash algorithms, authentication, group, lifetime, and then E is encryption. Haggle. So if you are following this sequence, or you won't forget that the points, or you won't forget the things you have to configure in phase 1. So if everything is matching between 2, and there are 3 matches which are same, then priority will be taken into consideration, and the one with less priority. Okay, sorry. One with less priority will be taken into consideration. Lower the priority number preferred is the policy. So suppose if I'm given 10, then I can go with 9 more such policies before 10 if I want to prefer. So haggle, hash. Now earlier we used to use MD5, then we used to use SHA, but now in SHA also you see we have the latest one, which is called SHA 256. Something happened. Wait. Config T, crypto Isaac MP policy 10, hash SHA 6. Okay. Authentication, I suggest pre-share because we don't have certificate authority. Group, you can go with 2, 5, 1, whatever. And every group you see, the bit is different. So more is the group number, the bit is more tough and higher. So we'll say we'll take 5. Lifetime 86,400 seconds, that is 1 day. And encryption, again we'll go for AES, and in AES also we'll go for 2. So when I say show run pipe section crypto, see I created haggle, but again HAGLL you can't see. Why? Because we gave 86,400 second, which is the default policy or default lifetime. So instead of that, we'll give 86,000. And when I say show run, you can see now we have haggle, HAGLE. The next is crypto Isaac MP key. Cisco address where you want to send this key. When you said pre-shared, that is the method. You have to define the key also. Okay. Now we'll create an access list. Okay. Permit interesting traffic. So I will say IP. Anytime if my traffic from 192.168.10.0 goes to 172.16.10.0, then you initiate the tunnel. So this is interesting traffic. Both the LANs, that is the LAN from 192 is trying to communicate with LAN of branch. transform set. I told you transform set is nothing but a set which carries the algorithms which will be used for maintaining the confidentiality of the data. So I will be using AES, and for integrity we'll be using SHA-HMAC. Now we'll be using cryptomap command. Later on I will show you for virtual tunnel interface also. So I need to crypto map some name. So I say India. Okay. Some sequence number. It can be anything. You can keep 5 also. IPsec ISAC MP. This is nothing but we are just clubbing IPsec and ISAC MP. But he is telling that you have to set transform set, T set in it. Set here 12.1.2. Okay. Match address 110. Then you go on interface. Facing over WAN and apply it. What is the command? Crypto map, capital I, India. You see, so how many commands you did actually? So you will not believe you did 14 commands approximately. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 access list, and then finally you went to interface and apply. Now whatever you do it on your first router, you have to do this on the second router also with some changes. So what is the changes? You have to do it. So this is my first router. So total 14 commands. I'll go and copy, paste it here. Now here for R2, its peer will be 12.1.1.1. Source will change. And finally you apply this. So suppose this is your branch, Dubai. So instead of India, I'll make it what? You can change this number. You can keep it anything. Not a big deal. No need to have the same number. Okay. So you see my policy number, that is priority number is 11. My sequence number is 10. So I created a policy. I described or I specified the method of authentication, and then I defined the appreciate key and where I'm going to communicate with. Then I created transform set. Mode tunnel is by default. I told you what is the difference between tunnel mode and transport mode. T set is the name of the transform set. You can keep anything. ABC also it's okay. For data confidentiality, it is AES. For integrity, it is SHA-HMAC. Now you go here on router 2. Start. Some issue. There's some issue with this UNL file. Anyway, I'll make a new one. We can also use CSR router. Let's see. This works. One, two, three, and four. G1, G1, G0, okay, G2, G2, and then G1, G1, all gig ports. Let's see if we can start this. So 32769. I think we need to configure the basic configuration. Let them start. Meanwhile, we can do some basic configuration also on this. What is the basic configuration? Config key, interface, whatever. G2, IP address, 12.1.1.25.25.25.0. No shut. Interface G1, IP address 192.168. 10.1.25.25.25.0. No shut. Same thing on R2. Interface G1, IP address 12.1.2.25.25.25.0. G2, IP route to go anywhere on internet. Go to next hop 12.1.1.2. It will take some time to start. Taking a lot of time. E0/0, E1/1, E0/0. So I'll go here, start it. The first thing I'll give is what? Mostly. E0, E1. Copy. Show IP int brief. Okay, it is E0 by 0. My mistake. So first we'll paste the basic configuration on R1 and R2. So can I ping? This is my head office PC. .10.2. IP default gateway. We are enabling telnet. Two by 5.0. So now we give the default gateway for branch PC. So if everything is good, we can ping 192.168.10.1. Twelve dot one dot one dot two. E0 by 0. Okay, we did mistake. Default interface E0 by 0 by 1. So always see first end-to-end connection is there or not. If it is perfect, because VPN is not going to give you connectivity. So what we have to do now, go here and say more action, export all configuration, startup configuration. So now you see, you have the configuration saved also. And now we'll paste our VPN config. Where you're going to apply this VPN? E0/1. Because if you see, my outside interface is E0/1. Show crypto exactly MPSA. First, looking at the phase one, show crypto IPsec. So phase one and phase two is not up. So let's send some interesting traffic from here. So I say 172.16.10.2. The first packet will be dropped. Second drop should work. Let's see. Show crypto exactly MPSA. Will not there. Show crypto IPsec HC. Where I pasted the config. I will go again and paste the configuration of, I think I did a mistake, so not pasted. So later on we'll see the troubleshooting part also. Show crypto Isaac MPSA. Still not there. Once again we'll trigger the traffic. See, first packet drop. That's okay. So phase one up. Here idle state. Phase two, you can see 5 plus 4 packets, ping packets. 9 packets got encapsulated. Suppose you go and do telnet. So anything you send, the packet will get, see, encapsulated and decapsulated. So always whenever you are forming VPN, you first have to check whether your phase 1 is up or not. So for checking whether phase 1 is up or not, you have to give the command show crypto ISAC EMP SA. And then the command is show crypto IPsec SA for looking at phase 2. You can see how India is trying to communicate with Dubai, that is through between head office and branch office, site to site VPN, and the protocol ESP, which is protocol number 50, and EH protocol number 51, and then ISAC MP, whose port number UDP port number is 500. You can see. Now the drawback is like, if you're doing crypto map, okay, you have to apply this on physical interface. So we won't do with crypto map methodology. We'll do it with VTI methodology, virtual tunnel interface, side to side with VTI method. Now, what is the difference between a VTI method and crypto map method? In crypto map, you have to apply the crypto map on physical interface. Now, if you get same features, everything same on a virtual tunnel interface, then what the benefit you're getting, you can go for many side-to-side VPNs and you don't have to restrict yourself to a physical interface. You can go on creating virtual tunnel interface for doing side-to-side VPN. So now we'll be looking at the scenario where we have 3 locations, okay, or we are having side-to-side VPN. Okay, so in this example, I have showed 2 locations, okay, no problem, or 3 locations. So we'll see that VTI method. Let's switch off this. VTI hub to spoke methodology, virtual tunnel interface. Here, if you can enjoy the same features in virtual tunnel interface also, same what you have done in physical, then why not go for virtual tunnel method? So in this scenario, if you see, we have 3 locations, R3, R4, R5. And we have this configuration with us, where we are going to send our traffic to 3 locations. Okay. You won't be specifying the address. Okay. So first we'll do the basic configuration. Just see the diagram. You have 10 network, 30, 40, and 50 network on, various spoke routers. So we are doing hub to spoke topology. These are the public IP address. Okay. So let's first delete this router because there's some issue. And I will delete this router also. 5 routers. One, two, three, 4 and E0 by 0, E0 by 1, E0 by E0 by 3. Zero by 0, 0 by 1, 0 by 2, and 0 by. Let's start. First, we'll do basic configuration. Go and on R1, interface E0 by 0, IP address 12.1.1. We'll create a loopback. To define the go to 12.1.1.2. Copy. To E0 by 1, 2, and 3. E0 by 2. Copy. 24.2. You don't need any route. This is an ISP router. R3. R3 spoke 1. Twenty-three dot one dot one dot 1, 30. Next stop. 23.1.1. R4 spoke. Copy. Paste. 24, 40, 24 dot R5 spoke 3, 25, 50, 25. So 2 and 5, 25, 2 and 3, 23, 2 and 4, 24. R1 Go to R2, paste it. The ISP router. Now we are configuring R3 router. Sorry. Yeah, R3 router. But I did some mistake. On R3 router, I should do what? 30. And this should be what? 23. And this should be what? R3. This will be R4. Will be 23. This will be 24, 40. So 30, 40, and 50. 25, 25. So I just take a copy, go to R3. First name, R3, hook 1. Okay. So if I ping 23.1.1.2, I should get ping. What about my R2 configuration? Show IP/INT brief. It's up. Show CDP neighbor. E0, E1, E2. As per the diagram. And then E3 also. $25. So IP/INT. 12 is hub, 23, 24, and 25 is what? Spoke. So IP/INT brief. Okay. 23 1.1.2 should ping because there is a direct connection between. No, we did a mistake here. As per the diagram, it is E0 by 1. So we say default interface E0 by 0. Go to E1. No shut. So IP/INT brief. So I go here and say 23.1.2. I can see. So all the spokes are on one side. R4. WR. So IP/INT brief. ping 24.1.1.2 should ping. But again, you did some mistake. Should be on E0 by 2. I go here and say interface E0 by. First, I have to make this interface as a default. Say interface E0 by 2. So, meanwhile, we are doing troubleshooting also. If we do wrong, if we choose wrong interface, what happens? 12.1.1 directly, if you see, I can ping hub. Go to R4. 24.1.1.2. Perfect. So 23, 24, only 2 spoke is enough. So you have one spoke, one hub, R1, R2 act as an ISP, then R3 and R4. So end-to-end reachability is there. See, 10.1 should go to, if it is not going means, you need to have some routes on R2. Okay, so once your tunnel is built, because now what happened when I say show IP route, I have a static route that anytime if you want to go to any network, go to 12.1.1.2. Just because there is no tunnel and there is no route on ISP router, that is R2. Okay. So we'll go and make a VTI tunnel interface. So you see, instead of this, it is AES 86,000 SHA 256. Cisco is the key, address 000. Then you do what? You create a profile, IPsec profile. You call the transform set. You create one loopback. So I create one loopback, say 1, not 0. 0 is already configured with LAN. IP unnumbered loopback means whatever IP address I keep on loopback interface, the same IP address will be taken into consideration for tunnel interface, because you'll be making many tunnel interface to point towards spoke. So you'll be having routes also to reach there. So you see, crypto ASAKMP will work, address crypto transform set. So I just copy this. I need to use config T command. We go and paste it. What is there on loopback? One private IP address to point to, because we said IP unnumbered, no? So when I say show IP INT brief, you can see I created two loopback, one for LAN, one for tunnel interface. Then I created a policy authentication group lifetime hash. He never took it because he must have taken it as a default. So it's not going to show you. Then what? You create a profile, call the transform set. You give the route to reach 30, 40, and 50 via tunnel. Then you create a tunnel interface, IPN number loopback 1. Tunnel source will be public IP 12.1.1.1. Tunnel destination will be 23.1.1.1. That is R3. By default, the tunnel mode is GRE, so you have to change it. And then finally, you apply the profile. So I go here and paste it. So IP route. So run. See, I created a tunnel interface. So when I say show IP INT brief, I can see that tunnel is on. Let's see. Tunnel source, tunnel destination, protection. Created IPsec profile name ABC. Call that profile in tunnel interface or tunnel interface. Now you go and create R3, same policies. So encryption, I kept it. Okay. Here you can keep single IP also. You can do unnumbered also. Source is the public IP, destination is this. Okay. To reach 40 network, I should say I should go via tunnel. So I go to R3. Now my source will be 23. Rest all the same. To reach 10 and to reach 20, 40 and to reach 50. Now if I send the traffic, so many times we have to troubleshoot. 30 is not going via. So crypto Isaac MPSA. So crypto IPsec SA. So IP route. To reach 30, go via tunnel interface. Now you see tunnel is up. Can I ping the tunnel interface of R3? No need of 4 because we'll be using 4 for tunnel interface of R4. So I just keep it 3. No shut. Show IP route. So to reach 10 network, I said go to tunnel 0. So when I ping 192.168.10.1 via 192.168.30.1. See, I can ping. And when I say show crypto Isaac MP SA, and when I say show crypto IPsec SA, you can see number of packets getting encapsulated. Now I'll bring this R4 up. Same process, config T. Same algorithms. Definitely 4. Source will be 4. Copy. To run. Okay. Never took that encryption. So it took default encryption method. Okay, it didn't took the command. Anyway, so show IP INT brief. So run interface tunnel 0. Source is 24.1. Destination is show crypto Isaac MP SA. Show crypto IPsec SA. 0 packets got encapsulated. Show run. Show IP INT brief. Okay, so I'm on R4, 192.168. I want to ping with the source 192.168.40.1. I should be able to ping from 40 to 10. So when you go for this hub and spoke with multiple tunnel interface, there is a lot of confusion in terms of routing also. Because now what we did, we said to reach 30 network and 40 network, go to tunnel interface. Okay, because we will be having 2 tunnel now, between 12 and 24 and between 12 and 23. That's why if you see, but now I have not created any tunnel interface on the hub side. Reach sky. So I'll go here and copy this. So IPINT read. So IP route. So I should say to reach 40 network, go to tunnel 1 and not tunnel 0. What about this guy? So IPINT brief. Tunnel is also up. Can he reach tunnel 1? show crypto Isaac MPSA, show crypto IPsec SA. 5 packets got encapsulated and decapsulated. So it's trying to send. See? And can R1 reach? With the source 192.168.10.1 via 2 tunnels. Tunnel 0. IP address will be same. Why? Because we said IP unnumbered. Okay. R3 can reach 192.168.10.1 source 30.1. R4 can also reach. So IP INT brief tunnel is up. So today we did, okay, what is the command? So for phase 1, show crypto Isaac MPSA, show crypto IPsec for phase 2. So this is a VTI method between hub and spoke. There are 2 spoke, R3 and R4. It is very easy because you have to just edit and paste the commands. Show crypto Isaac MPSA, show crypto IPsec SA. So later on we'll discuss what is the drawback of having hub and spoke with virtual tunnel interface and why they came out with DM VPN, dynamic multi-point VPN. But I showed you site-to-site VPN with crypto map. I showed you hub and spoke VPN between R1 and R3 and between R1 and R4. That is also kind of a site-to-site between R1 and R3, R1 and R4. And I use virtual tunnel interface method. Okay. I hope you understood. I hope you like this session of VPN. Okay. Thank you very much. Take care. Bye bye.